mentioned before, 98. The encryption number we obtained 40. The relationship I obtained 23. And we have taken a text, sorry, and this is the final, the matrix which I have used for the encryption purpose. And then we have taken this small passage, and after encryption we got this. Okay, and you can see this almost we cannot find it out. Although I know that those who have cryptanalysts or those who working in this area, you will be knowing that it is not very difficult to predict what is the actual thing. In fact, this happened also in my life. I present this paper in the month July, 18 July most probably in Las Vegas, US, and the hall was entire hall was full, and there are many research students. They are waiting. They are also voted on my class, and but one boy, he was very intelligent, and he said that he asked me many questions. Some of the questions I could answer the questions, some of the questions I could not answer because that time I was not so expert, so I could not answer. But I said that please give me your questions. I'll try to send the answers when I go back home from Calcutta. I'll try to answer your questions. Now, finally, that boy said that please send me some encrypted text, and I will decrypt it without knowing without your method, without knowing the actual method. I was quite surprised, but then when I came back to Calcutta, then after a few days, after 7 days probably, I sent a small encrypted text to that particular boy, and he sent me back after 3 or 4 days. He sent me back the plain text. I was totally surprised to know that he could do it because there are a lot of issues in this method that you have to understand. This is not a foolproof because what is the main idea? The main idea is we take a small, a block of 2 characters. Now, once we take a block of 2 characters, that will always remain the same after encryption. So that was the main drawback of this particular method. And so he basically tried to explore that, and then finally that boy dictated the text, and he sent it back to me. So I thought that we have to upgrade our method. So I just stop it here. Then I want to go for the next method. So we immediately we start to work on it. How we can upgrade the method. The MSC method was very simple and also interesting to apply, but it is not 100% foolproof because that boy already has hacked it. That means if he can hack, then anyone can hack. So I thought that why not we increase the size of the key matrix? Then probably it will be difficult for anyone to get the information. So we start to work on it, and then again my BSc students. Jipto is my BSc student, and Joyce, she was doing MCA. Subodhi was my BSc student. So this was his BSc project for the Jipto and Subodhi, and Joyce, this was the project for his MCA from Calcutta University. And we finished our work. It took say about 1 year time to finish the work, about 1 year time. Actually, we start to work it early in the year 2009, but we finished it in the year 2011. And the paper was published from the IEEE Explode, and we presented in SMVTU University, Jammu, and it was appreciated by most of the participants. Let us see how this method is better than the previous method. In the previous method, what we have done is we considered a key matrix, and the size of the key matrix was 16 cross 16. But here, in the DJSC method, the modified, upgraded version of MSA method, we consider a matrix whose size would be 256 by 256. Let me write it. Then probably you'll get some idea. 256, sorry. 256 by 256. Okay. Because I'm unable to use my whiteboard. So this is the size of my key matrix. Now in this key matrix, why this size is 256 by 256? What we have done is, we instead of taking one character, now we have taken a word of having 2 characters. Each word contains two characters. Now, total number of alphabets, total number of characters we can access in computer. How many? 256, starting from 0 up to 255. So therefore, if you take, suppose I start with say ASCII 0, okay, the first line. So ASCII 0 should be combined with 0, then 1, 2, 3, 4 up to 255. So the first row contains how many cells? 256. Second row will be starting with 1, and then 1 will be combined with 0, then 1 with 1, then 1 with 2, 1 with 3 up to 255. So second row also contains 256. So that way you have got total 256 rows, and similarly you have got 256 columns. So the size of the matrix is now 256 by 256. So total number of elements you have 65536. So now this is pretty large. And so if you want to apply brute force method, it is almost intractable. You will not be able to find out what the key matrix we have used. Okay, because you have to apply 65536 factorial times. So that is not possible. Maybe the hackers can do it, but at least we cannot do it. So the key matrix, not a single character. So that's the difference with the MSA. But the race part is same, almost same. So now we generate a random matrix. This 256 by 256 multiplied by 2, and that is done from a text key. The way we have done in MSA, same way we will be doing. The user will supply some text key, and from the text key, you have to calculate something like the randomization number or the shuffling number, encryption number, and also encryption number. These two things should be calculated using MSA algorithm. And then now, how to randomize it? It is now difficult because 256 by 256 elements, how can I store in the computer? We tried it, also Victor also tried it, but we failed because at that time we are using the C language and it was not working. It was giving out of memory, so it was not working. So we thought that instead of doing that, we split all the elements into 16 different blocks. Each block should have size of 64 by 64. Here it is. So instead of solving the full matrix in one shot, what we have done is we take 16 blocks, and each block we apply our method separately. So we apply our shuffling method, block 1 first, then you apply block 2, block 3, block 4, etc. All the blocks, 16 blocks separately. And then after that, we write it on the file, in external file, in a random fashion. That means block 1 should not be written here but somewhere else. But that I cannot disclose here. We have used our own way to do it, and it will be also random. Next encryption, it will be again changed. So essentially what we have done is, we have taken a block, the size of the block is 64 by 64, and each element have 2 characters length, and that we randomize, and we do it for all the blocks. Then we dump all the blocks in a random fashion in some output file. Okay, so that gives us our initial key matrix. After that, what is the encryption process? Encryption process will be again same. We now from the given text, what I'll do is we'll take 4 characters long text, and the 4 will be divided into two blocks, 2 and 2. So instead of taking 2 characters in case of MSA, now we'll be taking 2 words, and each word will contain 2 characters. So that's the changes we have done in BJSA, and then we search the matrix same as before. So therefore, here the randomization methods we have applied a little bit less because as such the method is big, very time consuming. So we reduce the number of randomization process. So we take cycling, we take up shift, we take right shift, down shift, and left shift. But one thing you have to keep in mind: right shift and left shift should not be one after the other. It should be always, there should be a gap. Otherwise, if you apply right shift and if you apply left shift, you will get back the original. So that is not our target. So right shift should be far away from left shift. So here the operations are very less. So I put right shift, then after that down shift, and then after that left shift. Similarly, down and the up shift should be also well separated. So up shift, right shift, and down shift. So that is a mandatory. Okay. Now we want to show it in a 4x4 matrix. Okay. Let us have a look. Suppose my matrix is this. This is a very simple matrix I've taken. Suppose AB, AA, AB, AC, AD, BA, BB, BC, BD. So these are my original matrix. So if I apply cycling, what will happen? This will happen. So this will be rotated clockwise, and the inner one will be rotated anti-clockwise. After cycling, then we apply up shift. Up shift is very simple, just one up, so circular up shift. Next one is right shift. So the whole thing will be shifted by one, but sometimes we use also multiple shifting, but initially for one right shift and then downshift. Downshift means just one down. So you can see. So finally we obtain BA, AA, AB, AC, CA. So now this is slightly different from the initial. Initially it was A, AB, etc. But now this has modified to this. And because we have got 16 different blocks, so each block will be also will be a totally random pattern, and we also dump it in a random fashion. So ultimately, everything will be random. So that is our main target. The key matrix should be totally random, which cannot be predicted from outside. So here I've shown this initial matrix. After conversion, I get this. Okay. So how to encrypt the text? Suppose we have to encrypt BA and CA. Suppose I have got a text in my my plain text BA and CA. So what I will do? I'll first find out where is BA. BA is okay. Let me just try. No. We have to find out where is BA and CA. So BA is here, and where is CA? CA is here. So it comes in the same column. Okay. So I have to take the next character, next alphabets from next entry from here. So BA, for BA I'm taking BA, for CA I'm taking BB. So BA is this. So similarly for the other also the same way. I've taken the encrypted text. Then so we got the final encrypted text. Now for the DJSA, what we report in the paper, we use the same text key that is AC. It can be anything, and then we obtain a small randomization number 50, because if it is large, then it will be also, it goes very slow. Because we tried this method to apply on a big file, and we saw that it takes about 10 to 15 minutes time to encrypt a big file. So that's why the randomization number and encryption number, these things should be small. If it is very large, it will take unnecessary extra time. Then I've taken some example here. So these are original text, and after encryption, this is coming. Now this is slightly better than the MSA, because now it will be really challenging work to hack or to predict what you have inside the text. It will be difficult. Although I should not say impossible, for me at least now, if you tell me now, definitely I can decrypt without my method, because now I know many other tricks also. So if I apply those tricks, probably I can find it out what is the original text. Maybe not 100%, but at least 60 to 70% I can get it from the encrypted text, because there are some standard logic, and if you apply that, you can definitely find out, because there are hardly anything we have applied. Anyway, but this was a very good method, and it was appreciated by many people. So what is the strength? The strength is the size of the key is very large, 256 by 256. So that's a big the challenge for the hackers. Maybe if they want to hack, they may not be hack the thing. Now, where we can apply? I mentioned here, this is my idea, like in this pandemic situation, because nowadays, so most of the day we just spend to send the question paper. So maybe we can, before we send the question paper, we can encrypt the question paper, and you can send it to the COA office or to our HOD sir. Okay. So in the intermediate stage, no one should be able to hack it. At least the students will not be able to do anything, because I know there are many students, those who are expert in hacking, and if they want, they can always hack the mail. All right. So this may be one application of DJS. All right. So MSA, DJSA, more or less same. Both are basically, you can say that this is the extension of the upgraded version of the Playfair method. So the output will be more or less similar type. Now, but the main drawback of these two, the first two methods which I described now, is basically we have not done anything in the bit level, and if you do not do anything in the bit level, the main drawback is those who are the hackers, they can hack very comfortably your data, and they can find it out what the data inside in that particular encrypted text, if it is not bit level, because character, because we have done basically character level and basically shuffling. So shuffling is basically what? You have got some arrangement and then you just shuffle it. So if you can bring back the original thing, then everything will be decoded. So therefore, MSA or DJSA, that way it is slightly weak. Because basically that was basically a shuffling sort of thing. So once you can apply this, the reverse process, then it's very easy to find the original text, because we have not applied any other change, any other method to change our text. So therefore, these are the drawback of MSA and DJSA. So we try to add some extra things so that will be much more difficult for the hackers to hack. So we define a new method where we apply some bit level encryption algorithms, bit level methods. Again, these methods, we have done with my students. They are all BSc students, and we this paper we presented in the same video international conference, IEEE conference, and it was published from IEEE Explore also, and it was appreciated by many people. And I also want to remember here, one of our teacher also here, Professor Amlan Chakraborty, he also contributed in this paper, and it was published in 2011. Let us see what is this work. Maybe I'll be able to discuss one more, then I have to finish. I have to back up. So here we just add extra thing, like we use a bit manipulation method, which include bit exchange, right shift method, and XOR operation on the incoming bits. Okay? To exchange the bits, the authors used a randomized key matrix. The size of the matrix is 16x16, using the method developed by us. Okay. To initiate the encryption process, the user has to enter a text key which may be maximum of 16 characters long. That is actually true for all the past papers also. And from the text key, the author have calculated the randomization number and the encryption number, same as before. So I don't want to discuss it again. Okay, now the present method is a block cipher method, and it can be applied to encrypt the data in a sensor network or in the mobile network, which I just proposed, but we have not tried it. Let us go to the next slide. Now let us see what is the bit manipulation. Apart from bit manipulation, the rest are basically MSA algorithm. So let us see what is the bit manipulation part. So first of all, we read 32 bytes at a time from the input file, and then convert the 32 bytes to 256 bits. Okay, and then store in one-dimensional array. So 32 bytes, 256 bits, and store in one-dimensional array those bits. After that, what I do? Choose the first bit from the bit string, and also the corresponding number in from the key matrix. Key matrix already I mentioned. We have a key matrix 16x16 that we randomize, and from there we obtain the value, and that particular value, that particular bit number I exchange with that particular bit. Okay, so this is the exchange operation. Next is, now we repeat this step for the second bit, third bit, fourth bit, etc. For each bit, what have to do is we have to get the information from the key matrix, and then that particular bit to be taken, and that to be interchanged. After that, we perform the write sheet operation by one bit. For the 256 bits, we give a write sheet by one bit, and then we perform the XOR operation. That is, we perform bit 1 with bit 2 XOR and a substitute the bit 2. Then 3 and 4 substitute the bit 4. Then the last bit also same, and a substitute the last bit. Okay, because we know that XOR, if you perform twice, you will get back the original. So that's why in the cryptography, all of us we know that the XOR is the most useful operation, and because if we apply XOR twice, we'll get back the original text. Because one thing you have to keep in mind, when you apply the bit manipulation, or the when you change the bits, make sure that it should be able to restore the original bit. Suppose I apply the suppose a bit operation like I change the bit 0 to 1 and 1 to 0. So that is called the changing the bits. Okay, and then after that we have made many more changes. Then when you want to come back to the original bit, then make sure that that bit should be again changed back to 1 or to 0. And if I don't do it, then ultimately I'll not be able to get back the original bit string. So therefore, when you apply the bit manipulation, then you have to be very careful about the operation, what operation you have performed, whether you have used the complement operation. When you apply the complement operation, you should be very, very careful. Or when you apply left shift or right shift, you should be very careful whether you are losing any bit. Because if you lose any bit, then you will not be able to get back the original message. So actually these things will understand or will appreciate when you actually work hands-on. If you do not work hands-on, it's very difficult to communicate to you. You will not appreciate what I'm saying. But I'm sure some of you are already doing it on machine and you have the idea, so you know what I'm saying. Okay, so after that, we do it for all this thing, all the bits. Then after that, we apply the MSA. So once the bit manipulation is over, then we convert a bit to a byte. Then again, we apply the MSA algorithm, which I've already mentioned before. So the difference is here we do something bit level. Once it is done, we apply the MSA. Then again, if I want for the starting from the bit level, we do it. Bit level changes, then again MSA, again bit level changes, MSA. So that way we make it much interesting, than the previous one. And after we do that, I just want to show the results. This thing, because of the bit level manipulation, it will be not difficult to find any sort of pattern, good pattern. Even if you apply some known plain text attack, if you apply known plain text attack, I also did the same. I applied the known plain text attack, then brute force attack, but I saw that it is not possible to find the original text. Okay? So that's the beauty of this particular method, NJJSAA method, where we apply partially bit manipulation and then MSA also. Let me see if I can cover one more method. Maybe I'll just take another 5 minutes and then finish. Now, I think this will be my last method. This is pure bit level. Actually, after doing 3-4 work, in fact, between 2010 and 2012, we published about 10 to 15 papers on cryptography. And we saw that we got a lot of communication from many scientists and also from the students. And they suggest me that you go for pure bit level encryption. Otherwise, your method will not be very successful. So we start to work on it. And then again, they are my BSc students, Gaurav, Tanya, Sumik, and me and my Joyce also. Now, these I present this paper in US in 2013. I present this paper and it was appreciated by those who were present there in the meeting. So this is actually bit level encryption standard number version 3. That means before that we have also version 1 and version 2. But naturally version 1 and 2 I'm not discussing because there is some loopholes and some problem also. But in version 3, all the problems have been taken out. There is no problem here. It is fantastic. So let us see what we have done in version 3. It is pure bit level. We have not done anything other than bit level. Basically we have used the columnar transposition method in random order. Columnar transposition method is a very standard method. So those who know the cryptography, you know that we first put the characters in columns, in different columns. Then we just take the columns in random fashion. Okay. So instead of taking the characters, we just put the bits, and then we correct it in random fashion. Okay. And then after that, we apply a bit level generalized Barnum cipher method, and also XOR operation. Now, this generalized Barnum cipher method actually we proposed in 2012 most probably. Yeah, in 2012 we proposed. That is again my BSc students, they have done it. The Barnum cipher method normally we apply for the characters, but for the first time we apply for the bit level, and also we add the feedback. That's an additional thing we added there. So that makes the program very, very versatile. Very, very versatile. So in bit level version 3, we apply this particular issue, and then after that the XOR operation also. Okay. And then let's see. I just, because of the time short, I will not be able to show everything. I just want to go to the results. I think that will be much better. So here basically we perform the XOR operation and also the columnar transposition method and also the generalized Vernon cipher method, but in the bit level, not in the byte level. Normally, we perform the Vernon cipher method when we teach in the class also. We do it for the character level. But we proposed in 2012, we did it for the bit level. There are a lot of problems also, but still we work on that, and it will be very, very interesting if we can apply it to the bit level. Okay, and I just want to show, there is a result. I just want to show it because the results will give you definitely some idea. This is we take 1000 ASCII 0 characters. What do you mean by ASCII 0? Here I have given an idea. ASCII 0 means all the bits are 0. So 8 bits, but all the bits are 0. So if you want to see anything, it will show nothing. And the size of the byte is also 0, no size. So that type of characters, we choose 1000, we store it in a file. Then we apply our encryption algorithm. So if you apply the encryption algorithm, normally if you apply any other encryption algorithm like DES or maybe RSA will fail. RSA will never work on ASCII 0. So if you apply DES or AES or any other standard method, but you will see that it will never work on the ASCII 0 because all bits are 0. So no algorithm will work. But our method will definitely work because we apply some unique sort of operation bit level like XOR operation, then we apply the complement operation, so many other operations we apply. So we can see that even if it is ASCII 0, the output we are getting totally random. You see, all possible characters are generated. So it will be difficult for even for the expert also. What is actually the plain text? Although I've taken only ASCII 0, but you see the output is coming totally different. All possible spectrum is coming. Similarly, I did it for ASCII 1 also. ASCII 1 means what? Only one bit is on, the rest are all 0. So normally, if I apply a standard method, it will never work. But fortunately, it will work here because our method is bit level this thing. Okay. So, and here is one more example. So, I think I have to finish it here. Bit level encryption now. In fact, nowadays the last couple of years, we are engaged with doing the research work on bit level only. Plus some we have started to work on the chaos also. We apply the chaos on the bit level, and then we see what type of encryption we can get. And many more, and noise also. We apply the noise, and then we see how we can get it. Unfortunately, this is also a very good method. Already, this was said that we got this paper award in 2013, but because of the paucity of time, I'm not been able to discuss. But all the the references are given. So those who are interested, please go through my references. If you want, I can just give the PowerPoint to Topolania, and I hope she will circulate to all the participants. To go to the last slide. Yeah, these are the references. Not many. I have published more than 60 or 65 papers in encryption, but here I have given a few, not all. Now, here just I want to acknowledge. First of all, I want to acknowledge. I'm very much grateful to Topolania, Dr. Topolania Bhattacharya and Professor Umid for giving me opportunity to deliver the invited talk on cryptography. Although I know that my topic is far away from HPC, but I hope the participants now will take initiative to work in my research area. And I'll be very happy if someone is interested and if someone volunteered to work with me. I'm ready to help you. I'm ready to work with you. I'm also grateful to Joystree because she has corrected all my PPT slides. I just prepared initially, but then he corrected. But she now staying in Canada. From Canada, she has done it. I'm very much thankful to Joystree. Last but not the least, I'm grateful to Father Dominic Savio, our beloved principal of St. Xavier's College, Kolkata, for giving me all-time inspiration to do research work in the field of, spelling a mistake, field of science and engineering. So once again, thank you very much. So if you have any questions, I know the time is short, but still if you have any question on my topic, you are most welcome to ask me. Thank you very much.
Thank you, sir, for delivering your such a wonderful lecture and sharing your research work and in-depth knowledge on advanced symmetric cryptography algorithms. And thank you once again, sir, for accepting our invitation. Thank you, sir.
Okay, thank you.
If you have any question, you can ask.
Yeah, I'm here. Please. I just want to add one thing I forgot to mention. If someone is interested to work in cryptography, then what will be the basic requirement? Basic requirement is actually absolutely nothing. anyone from any background can work, but there is only one issue is there. You should have the patience. Patience in the sense, you have to always keep in mind that there is 99% chances that your work will never work. I mean, your work will fail. So you have to only work for 1%. And that 1% again, maybe sometimes less, maybe 0.1% also. So that is the most important issue. And the patience. Patience, and you should be also hardworking. And the last part is, you should have a solid knowledge about file handling of any language, maybe C or Java or maybe Pascal or any language. The file handling should be very, very, important issue in cryptography. Okay, so if you have any question. All right, so thank you very much for your patience.
Thank you, sir, once again. If there is no question, we can move to the paper presentation session. The first paper of this session is Challenges of Using Different Mathematical Models for Load Balancing Optimization in Multi-Core Computing System. That will be presented by Dr. Elviz Ismayilov from ASYU.
Thank you, Tapalina, and thank you, Dr. Ashok, for your presentation. Just let me to present. Okay, is it visible, my presentation?
Yes.
Thank you. So first, let me to introduce myself, to talk something about myself. I'm Elviz Ismayilov. I'm the scientific and administrative executor in High Performance Computing Center, Azerbaijan State Oil and Industry University, and also I'm the managing editor of the Azerbaijan Journal of High Performance Computing. Now I want to introduce to one of the important directions of our Advanced Research Center about the convergence of HPC and AI, and especially the second part of this convergence using the different AI techniques or different mathematical models based on the AI techniques for load balancing optimization in multi-core computing systems. The existence of enormous amount of data, importance of learning intelligent agents by large-scale training data for implementing their high-quality application, requirement of individual approach for each branch of artificial intelligence, time extending for learning of the deep neural networks, in most cases from days to weeks, and etc., makes unavoidable application of different high-performance computing systems, such as cloud, grid, peer-to-peer, special supercomputers. Appropriation of machine learning is endorsed to be an essential tool for the solution of problems, such as in such fields as medical diagnosis, designing of intelligent systems, predicting, etc. Nowadays, developing systems based on machine learning requires analysis of huge amount of data, regardless of supervised or unsupervised training. Under such circumstances, usage of HPC systems avoids delay emerging in training procedure and reduces several times required period. Recent methods concentrate on the solution of training problems in developing intelligent agents by proposing different approaches for convergence of HPC and neural networks. However, the main disadvantage of present systems is establishing only 4 neural networks of small size and the existence of limitations for the number of parameters. Researchers introduced more specific research for the development of supercomputers only for recognition, mining, or intellectual games. Some companies and researchers have also suggested establishing multi-chip architecture for CNN, convolutional neural networks, and deep neural networks. Reviewing of large-scale data mining of significant and unknown knowledge and facts from the enormous amount of information are the challenging problems of machine learning and big data. Superposition of the algorithm and parallelizing of the iterations makes it possible to decrease the time required for data analysis by solution of the problem in HPC systems. The main requirements for the application of deep learning are related to hardware attributes. Indeed, it is necessary to establish a hardware platform for storage of large-scale training data and appropriate for a large number of neural network parameters. From this perspective, utilization of HPC systems leads to achieve superior results. On the other hand, there are numerous efforts for reducing hardware requirements by application of different optimization problem algorithms which ensure satisfactory results. One of the main problems of AI is a single appointment characteristic of intelligent agents. This text recognition system developed for any language would not be able to show the results with identical quality. Application of HPC contributes utilization of machine learning system for AI tools with different engagements. Speech recognition of two different languages, as English and Chinese Mandarin, for example, proposed and investigated, which can be the good model for the importance of HPC in machine learning. The next direction is the big data analytics, extraction of useful knowledge from the massive scale of information, causal inference through the text summarization, text reviewing are the main problems of current research. Not only in applied sciences, but it also becomes to the main subject of social sciences such as political science, sociology, and psychology. Problems of decision-making and predicting through classification, analysis, summarization, and mental processing of existing information are in the central interest of the both HPC and AI companies and scientific laboratories. An important question integrated with big data classification developed via machine learning techniques is the difficulty of using big data analytics system trained in a particular dataset for another kind of large-scale information. However, the proposed approach for application of machine learning techniques in big data analytics have many problems related to data itself. So it is necessary to develop tools to handle mislabeled data, missing values, high dimensionality, and imbalance of training data, and for implementation of noise. There are also the alternative methods of AI are available for solution of different problems in design and development of the HPC systems, such as predicting of running times, resource utilization, optimization of load balancing, job scheduling, resource discovery, and process migration. Investigation of AI and HPC integration, so how you see, is carried out in two directions. Possibility of AI and HPC possibility of using HPC systems and parallel algorithms for solving of the AI problems, and also HPC models for data processing in big data analytics and handling problems appeared on the development of the distributed computing systems. Now, I want to get your attention to the second part of this convergence. So the application of the AI techniques for optimization of the load balancing systems using different techniques of AI based on reflex-based systems, state-based systems, variable-based, and logic-based systems. And let me to specify the application of these techniques separately in the next slides. As load balancing in HPC systems remains the base assignment between tasks and machines, applications of combinatorial optimization problem solutions can become a useful tool. In a recent study by several researchers, we analyzed, compared, and critiqued relevance of using evolutionary algorithms for task scheduling and load balancing in different HPC systems. Necessity of predicting resource utilization for incoming tasks and as a result handling the task scheduling problem enables to use neural networks in distributed systems. The application of neural networks for forecasting loads in cloud data centers under the condition of minimizing energy costs was successfully tested in cloud computing platforms. But the occurrence of the dynamic and interactive event in exascale distributed systems requires new approach and different methods of AI, which can give beneficial results in developing of such systems. And in his talks, Professor Musavi and also the researcher of the HPC Center, Etibar Vezira, gave the definition to the dynamic and interactive event. That's why I don't want to talk more about this. But I want to say that in case of the optimization of the dynamic load balancing, which we have the dynamic change also in the resources, both the resources and the processes, traditional discrete load balancing mapping becomes useless and appears necessity for hybrid load balancing mapping, which can be characterized as continuous function. The primary practical solution for this problem might be the application of the AI methods and fuzzy logic. Representing load balancing assignment by fuzzy graphs or definition of the fuzzy relations between processes or resources at different time moments might be one of the best solutions for job scheduling in distributed systems. In order to outline this approach, for tackling of load balancing problem in multi-core computing systems, it's useful to model the process as time series and represent each time step by parts of weighted bipartite graphs. Weights in these graphs can be determined as similarities of assignment process in consecutive time steps. As a result, we get series of weighted bipartite graph for each consecutive pair of time steps. The second part of the previous time step becomes to the first part of the next time step. The optimal assignment task to meshes can be determined after implementation of maximum matching algorithms proposed for bipartite graphs. Obtained graph networks give an opportunity to apply learning techniques of statistical inference and soft computing for automatization of optimal load balancing, which we'll discuss in the next slides. Bipartite graphs representing dynamic load balancing process in multi-core computing systems can be smoothly transformed to Bayesian networks. An advantage of modeling management process by Bayesian networks or belief networks is their ability to analyze data from different sources, including expert knowledge, and handle the learning process on case of missing data. Bayesian approach has been considered by different researchers for implementing of the overloading in load balancing process, as well as for finding most likely haplotypes through parallel research in dynamic systems. Also suggests application of Bayesian networks to the modeling of dynamic distributed computing system. This is mainly caused by information deficiency and impossibility to collect huge data for training using learning systems such as deep neural networks or convolutional neural networks. But opportunity to express dynamic load balancing process by time series and connect them in directed acyclic graph gives a chance to apply Bayesian learning algorithms based on conditional similarities between resource attributes and task requirements in each time step, as well as between assignments in each time step, and to determine optimal load balancing in each time step. In dynamic distributed computing systems, for optimal load balancing, which have to be developed for maximization of total throughput of the system, makes necessary to resource discovery and process migration. Uncertainty of these systems gives an opportunity to apply fuzzy logic for optimization of dynamic load balancing via expressing parameters of the system by linguistic variables. A review of major research in this area considered the using of adaptive narrow fuzzy inference system, or ANFIS, which combines two techniques of soft computing as neural network and fuzzy inference systems. This concept offers more precision on term of efficiency by providing advantages and eliminating disadvantages of both techniques. Our description for modeling of the load balancing in dynamic systems in case of dynamic and interactive event based on ANFIS approach is similarly founded on expressing of the assignment process by time series and to train ANFIS on each time step. The important task here is to define input and output variables of the adaptive neural fuzzy inference system. These parameters can be defined by several ways. First way is the task requirements can be the input variables and the resources as the output variables, and the output node that gets the highest value after implementation will be determined as the best matching. The another way is that the input variables will represent the resource attributes and process requirements, and the output variable will be the best assignment, which will be defined as by the highest value. During this research was proposed different approaches defined by mathematical models based on the graph theory and the artificial intelligence techniques for optimization of load balancing and exascale computing systems. Dynamic and interactive event, which can occur anytime during the execution process of complex tasks in multi-core computing system, makes difficult to manage the job scheduling. A solution we propose to express the process by consecutive time series and each time to apply different techniques of artificial intelligence. The evidence of the missing data and difficulty of collecting training examples makes ineffective to apply the reflex-based models. However, different techniques of artificial intelligence created as variable-based models and logic-based models can be helpful to implement the effective load balancing in dynamic distributed systems. There is a great deal of work to be done for implementing each of these approaches and to identify the most successful method for the different tasks. Thank you for your attention, and if you have the questions, please, I can ask.
If you have any question, please ask. Thank you, Nigar, for your good presentation.
Thank you.
If you have no question, you can call the next presenter. Next presentation is on challenges of using big data in distributed exascale systems. That will be presented by Firuza Khalikofa Tamazil, a PhD scholar of ASYU.
Hello everyone, I am here. Let me start my presentation. I am starting to share my screen. Okay, can you see?
Yes. Yes, we can.
Okay. Today I want to talk about the challenges of the using big data in distributed exascale system. And we have a big data and the EHPC. Now we explored the convergence big data and HPC. By the traditional way to store data and then processing them is not sufficient for today's data-intensive computing. When big data was appeared in web companies, the field of the science met a new data processing problems. The digital data are collected, stored, and analyzed, but it is tough to create real-time and computing. In traditional HPC is able to cope with the huge amount of data efficiently. The new problem is to find the convergence big data and distributed exascale system. Big data has a complex anatomy and decrease the HPC compatible with it. Our aim is to explore the problem in both sides, big data and HPC. This article main purpose is to find interconnected relation between distributed exascale system and big data. To find the convergence between these two systems, it should be explored nature of them. The nature of big data means its attribute, volume, velocity, and variety. For distributed exascale system, it means dynamic and interactive environment. Big data are kind of data that are contain some dynamic features in themselves. The difference between traditional data and big data is that big data have some features that are called attributes. They are volume, velocity, and variety. The volume it is a data set. The social media, the bank transactions, sensor embedded systems, the research laboratories generate and consume a huge amount of data in a second. The batch of raw data are storing at cloud computing system which contains many petabytes data. The scientific laboratories routinely process terabytes of data produced by their own instruments. The velocity, and what is the velocity? The velocity can be considered as the speed at which data are generated and transmitted. The data are not continuously streaming into the server in a real time and make the original batch process break down. In distributed system, machine-to-machine process exchange data billions of devices. And the variety, what is the variety? The big data can be structured or semi-structured and unstructured. Maybe the data and signals, 3D data, audio, video, image, and the others. The volume, velocity, and variety influence the executing big data in distributed exascale computing system. The runtime elements of big data are events, source, maybe remote sensors, people generate data, measurements, and transaction system. And data-intensive system share cloud infrastructure and users. The traditional high-performance computing system copes with a huge volume of data. The present real-time data in distributed exascale and dynamic distributed exascale system is changing periodically. Some nodes are joining the system or leaving, or they are out of the order. When the computing process are executing, some new processes start to run unpredictably. The nodes of the distributed communicate other nodes of system non-estimated in advance. We can look some problems in computing big data and OHPC system by taking account all two systems' nature. When big data systems are running on distributed exascale system, we notice unknown events appear. Resource attributes are dynamic. It influences process status. The processes are getting slowed down. Requests to read and write data circuits on many nodes. New processes are forked, created after fork operation. Two parallel topologies of data processing and many nodes. Data processing and end up system anomalies and latency. The other issue is the system depends on resource. The resource can join and leave the system without under control or unpredictably. Therefore, it is impossible to estimate how many data are income to system next per second. The distributed is different type and unstructured. Require multi-leg approach to this the parallel system. If you go to estimate, will be data influence the system processing. The obscure nature of the problems begin to create dynamic behavior in processes at runtime. Our purpose is to define the role of big data attributes in uncertain dynamic system environments. The process to investigate formational problems with basic questions as below. How value, velocity, and variability influence on a new system fork. How value, velocity, and variability influences on processes intercommunication. How value, velocity, and variability influence on processes. How value, velocity, and variability influences on where data coming and waiting for computing. To identify the relation between two systems, being big data and HPC, gives us to manage resources and getting high performance. The resources in a new generation distributed exascale system our mission to find external impacts on the system and manage the systems effectively. We assume that the big data nature will be able to change execution workloads in a distributed exascale system. It is important to know what interrupts or causes the latency execution of the process in an HPC. For this reason, we propose a holistic approach, a Markov chain model. In review connections. States of process data to increase all attributes of big data separately and big positional states which are related to distributed system. After implementing some transitions back, you can see from the presentation. When executing big data in distributed exascale systems, the execution process faces dynamic and interactive nature also. And our purpose is to find the role mediator role in this system. And if we want to find the interconnections, interconnecting relationship between them, we should identify all states of process. We want to identify if we start to increase the volume, velocity, and value of big data, what will system react? Maybe create a new process or not. The process start to interact with other process or not. The processes intercommunications or not. In the HPC system, there are a lot of processes that are executed simultaneously by parallel programming. To start with this program, we use the map-based chain model, and we suggest these transpositions matrix. You can see from this matrix all states of the process, new ready, random, waiting, and terminations. And in each P, E, and I, and J is probability of transitions from moving state from I to J state. The number I should say was the process, the number J indicates what state or process is going to remove. Our aim is to compare transition matrix each one level. We assign level with K variable. Initial level K equals 0. Then we start to increase the volume of big data. The velocity and value are still stable. All growth of them are very little. We note the system status for K equals 0, and next calculate K equals 1 level status. Maybe after increasing the volume of big data, the transition matrix will change. We can describe like this: the M matrix for volume, M matrix for velocity, and for the variation. And these three matrices maybe influence the system CPU, input and outputs, and memories. And we have here the matrix for volume, and for K0, for K1, and for K2, and others. We compare all transition matrices to find how the volume influences D and I. And for the others one, for example, for velocities and variety matrices we have here for different levels, and we compare them also. And we have here the other tables, charts. Here you can see how we can compare them. We create this chart. From this chart you can see we have a probability of the states, process states, which, for example, P11 means the state, new states, the still mean in the new start state again. For K0 we have the figures 0.3. For K1 we have figures 0.7, and we compare K0's blue lines and with the orange lines. And these orange lines show us the K1 level. We have a Markov chain model for the storage problems of the memory. The Markov chain model for producer and consumer processes. In operating system, we now some processes write data to memory, and the other process take data from this memory. It is called the producer-consumer processes. They share this part of the memory. This conception contains two nodes, what are write and read. There are four director edges, what shows how data come to memory and process, allowing to find how the data attributes impact on a runtime processing distributed exascale system in the storage data. We suggest again Markov chain model to identify impact of big data attributes on memory. For that, we create again the transition matrix for the memory sharing. You can see we have a states and write and read. For this states, we created transition matrix. We get transition matrix for continuum. PIG is the probability of the write and read nodes. Each element variation of matrix shows the process directions. For example, after increasing volume of big data, if P11 has grown, it means the value caused input output bottleneck. Normal is some processes are fetched data to memory, but the consumer processes are late to get data from this memory part. Obviously, said that we writing processes are propagating itself, but the consumer processes are not able to get data from the memory part. For all the attributes of the big data, same transition matrix should be created and analysis. After investigation of transition matrix and elements of PIG, we will obtain the significant results about internal processes in distributed exascale system. As a result, and also this implementation, this model will reveal accurate transition matrices. From here you can see the matrices. We have the matrices for volume, for velocity and variety. We first to compare them for level 0. Then we increase and create all matrices for these attributes, and again we repeat it. And in the other part of the it is called the same, because for the same levels we compare all attributes, and we have a different analysis approach is to increase the volume. First, we analyze it influence, how to influence the process in a distributed exascale system, and then we increase the velocity, create this transition matrix, and to analyze how this increasing to influence to exascale, distributed exascale system. For variety, the same things we are doing, and as a result we compare all these outcomes. For C same, we can get that it means the which increasing of attribute or attributes impact on memory sharing. C, different means in the same level what attribute or attributes impact on memory sharing. And we have give a conclusion about the comparing these transaction matrices. We have three types of the results. First, the A is called the figures of each level will be not various or the bias not in significant decrease than the previous level. The second one, the figures of each level will be various in a significant degree than the previous level, and each level of the figures are still increasing or decreasing. And the last one, the figures of each level will occur mixed variation. The variation trace will be up and down. It is related to this type of charts for all transition methods. We should to create these charts. As a result, we compare these figures and have to for attention. If you have a question, I am here. I am ready.
Thank you, Firuze, for presentation. And let's just to wait a minute for the questions. As I see, there is no questions. Thank you very much for the again. And I want to introduce the next presenter, the next presentation, Anomaly Detection Using Machine Learning Approach by Professor Mosimi Dasnat and Dr. Tapalina Batasali. Please.
Good evening, Father Principal, dignitaries, and all the other participants. Can you see my screen?
Yes, we can see.
Okay, thank you. So I would start my presentation of anomaly detection using machine learning approaches. So first, let me give you the outline of my presentation. First, I will discuss the background of it, why we are doing this, what is the motivation and what are the objectives of this work, then our proposed work, and finally we'll just analyze what our proposed work would achieve, and finally the conclusion and future scope. We see that there is a widespread or popularity has exponentially grown, or it has popularized the use of networks, especially internet, wireless networks, cloud computing. So voluminous amount of data are daily transmitted through internet due to enormous usage of internet. So thereby, increasing attacks on computer networks is on the rise. So what happens, as we see that internet and computer system have raised numerous security and privacy issues, which can significantly impact the confidentiality, availability, reliability, and integrity of sensitive information. So, why it is so? Because various malicious attacks on the networks have increased over the years, and the damage due to these attacks has caused maybe a little disruption or service to developing huge financial loss. So there should be an effective intrusion detection system which could monitor these malicious activities. And misuse or any signature detection approaches used in intrusion detection can monitor network traffic to detect unknown attacks. So what is the motivation of this work? So first thing, how to deal with unknown attacks. Anomaly detection method determines whether deviations from normal usage patterns can be flagged as intrusions or not. So we need to automate the systems to detect any unknown attacks also. Machine learning can be used to automate detection because they are well suited for automated detection of anomaly or not. So what is this intrusion detection system? An intrusion detection system, or IDS, is noted to be a second line of defense in network security. It can detect, prevent, and can take necessary action against certain unknown attacks. It protects from huge data theft as well as financial loss. So how is the intrusion detection system working? It has a data storage unit and a data analysis unit, which in turn can take the decision of intrusion. Now the data to these units is fed by a monitoring unit which captures the data and forwards it to these units. The IDS can be based on the result from this data analysis unit. And moreover, IDS can be vigilant and inform the administrator about any such intrusion or can take necessary action on its own. So our objective here is to find the accuracy, to obtain a high accuracy in detecting unknown attacks, low false positive rate, notification by intrusion detection system, adapting to continuously changing network environment, and reduce time consumption for faster computation. Now, machine learning in anomaly detection. Anomaly-based detection, it is easy when it is possible to characterize what is normal in data using simple mathematical models. And most interestingly, real-world systems have complex behavior that does not follow such distribution. So machine learning is useful to learn the characteristics of system from observed data. Feature selection is process of selecting a subset of relevant features, whether it's variables, predictors, for use in the model construction. Feature selection techniques are used for three reasons. One is simplification of models to make them easier to interpret, shorter training time, enhanced generalization by reducing overfitting, and outlier detection because it is an outlier is an observation point that is distant from other observations. Now, what are the challenges in machine learning based detection? Now, in case of outlier detection, it is very hard to define normal in network traffic as the usage varies in every session and with new applications. That means because of the diversity of network traffic, that is why it varies. High cost of errors, then cost of misclassification is also high, extremely high. False positive rate and false negative rate. In case of false positive, it is an expensive analyst time, and in case of false negative, it can cause serious damage to an organization. So, error in other applications of machine learning, not expensive, like OCR, spam detection, etc. But what are the difficulties with evaluation? Designing sound evaluation schemes can be more difficult than the detector itself. And another difficulty is lack of public data sets for assessing anomaly detection. Also, it is hard to gain real data set for many reasons, like for example, leak of personal data. Simulated data is also not accurate. So how we can improve this anomaly detection? There are three major steps in anomaly detection. One is the feature selection, one is the model of normal behavior, Normal behavior means whether it is an attack or any other type of, or it is an abnormal behavior. That is the model of normal behavior we should see, and we should do the comparison between two types of attacks. Now, the machine learning techniques proposed here: single classifier, hybrid classifiers, and ensemble classifiers. Now, the first step we are going to discuss is a single classifier, naive Bayes. It works on Bayes' theorem of probability to predict the class of unknown data sets, and it is one of the most simple learning algorithms. In this paper, we propose to use naive Bayes as a classifier due to certain reasons. First of all, it is easy and fast as it assumes the independence between features to predict class of test data set. Performance is noteworthy in case of multi-class prediction. Less amount of training data is required, and when assumption of independence holds, a naive Bayes classifier performs better compared to other models like logistic regression techniques. The next classifier we use here is SVM, support vector machine, a supervised learning method. It handles the anomaly detection accurately, outperforms unsupervised learning approaches. So SVM finds the optimal separation hyperplane, can deal with high dimensional data, and when combined with various other techniques, offers anomaly detection efficiently in a networked environment. SVM maps the input vector into a higher dimensional feature space. The decision boundary is determined by support vectors and extremely robust to outliers. Now we talk about hybrid classifiers. Here we are talking about hybrid classifiers where we are consisting of two functional components. The first component will take the raw data as input and will generate the intermediate result. The second one takes the intermediate result as an input and produce the final result. So, integrating techniques where the first aims to optimize the learning performance, that is parameter tuning, of the second model for prediction. So here you see after the classification is done, we find out whether it's a normal behavior or attack classes. So this is the approach we have first found out. This is a hybrid approach where we are using naive Bayes and SVM approach. First, the intrusion detection data goes to the naive Bayes and we obtain the intermediate results. This intermediate result is fed to the support vector machine. And after this support vector machine computation is done, we get the final result, the final result of classification. So how does this work? It is known as NVSVM, which has two layers for classifications. Naive Bayes works well in real time and consumes less time in computation. So initially the data sets were first passed through the NV classifier and the intermediate result is generated. Data generated is then again fed as input data to SVM. After going through the computation process of SVM, the final output is achieved. The final output then differentiates whether it is a normal attack or an intrusion. So what are the features of this hybrid layer approach? Naive Bayes, SVM and NVSVM classifiers have been used individually. It is noted that each classifier might work better and yield promising results in individual cases. It does not work well on large training datasets, and overall computation time is more. Not effective in all scenarios because we cannot expect that all scenarios will give a promising result. So in individual cases, it provides good results, but in all scenarios, in all cases, it is not that effective. So, because it does not give significant improvement when number of features and lot of training data are used, we propose an ensemble approach. So, atomic anomaly detectors, here we see when we find or take care of the records, we classify whether it is an anomaly or not an anomaly. Considering all the records, likewise it is analyzed. The analysis unit of the intrusion detection system finds out whether it is an anomaly or not an anomaly and stores in the storage unit. Why do we need to combine detectors? We see in individual cases there are too many alarms, and combined view is actually better than individual views. Whenever we are combining the detectors, when we are combining the models, we see it gives a better result. Finding out from the entropy values, we can figure it out. So in this case, we actually do not know which rules will be better, which atomic rules will be better and which will be worse. There could be bad detectors also, so that if there are bad detectors, majority voting cannot work well. So what is about the ensemble approach then? Ensemble approach is actually, it combines the independent diversified models and improves accuracy. No matter in supervised, unsupervised, or semi-supervised scenarios, ensemble methods have demonstrated their strengths. Base models are combined by learning from labeled data or by their consensus. Now this is an ensemble where we are taking the data, we are finding the different models and combining the different models into a common model known as the ensemble models. So combining different models into one is called the ensemble model. Applications of ensemble models is classification, anomaly detection, clustering, etc. Why ensemble works? Ensemble is actually, it combines diverse, independent opinions in human decision making as a protective mechanism. Suppose if we have 5 completely independent classifiers for majority voting, and if accuracy is 70%, we see the majority vote accuracy will lead to 83.7%. But if there are such classifiers where we combine it, we might have 99.9% majority vote accuracy. So ensemble actually reduces the variance caused by singular models, and it is more robust than single models when the distribution is continuously evolving. So our proposed work here is why I just informed you about the background of ensemble. So why we have used this ensemble approach here? Because it integrates the different learning models to yield better performance, increases accuracy, robustness. It is mainly used for statistical, computational or representational reason. Heterogeneous ensemble approach is used here. It involves usage of set of diverse and different types of base classifiers for deriving its final outcome. An efficient method is required to aggregate the diverse outcomes to get the final outcome of the ensemble classifier. Here, single classifiers actually fail to detect all types of intrusions efficiently in all situations, whereas simple ensemble approach helps to improve machine learning results by combining the several models. That is why we consider the ensemble approach here. It allows the production of better predictive performance compared to a single classifier. Also, it helps to overcome the challenges of a real-time IDS. It solves the problem of detection rate as well as high false positive rate. So here we can see a pictorial representation where we have the label data and different classifiers which combines to form an ensemble model. And this combination from the label data, they found this combination and they form the ensemble model. From the ensemble model, actually we derive the final predictions. So this is an ensemble of classifiers which we reach a consensus. From a label data, we get the training model, that is combining different classifiers. From this unlabeled data, we can combine the predictions by majority voting and we get the final predictions. As for analysis and discussion, we see that ensemble method works more significantly, as we are seeing that model I will predict y, that means when it is 1, otherwise it is 0. So we have a training set where different classifiers there and which will combine to generate a test set, and from there we get the final outcome, classifying output. So how is the working of ensemble approach carried out here? We use the highest scored class as final output among base classifier, also known as the majority voting method. Here we are using NB, that is naive Bayes, support vector machine SVM, and NB SVM together. According to performance on training data, each classifier is assigned different scores. Using these scores and outputs of the classifiers, final scores are calculated. Now, if 3 different classes for each classifier has different values, then depending on their performance on the training data, highest value will be termed as the final output of the ensemble approach. Now, if for any record, if any data record, naive Bayes works best, it is allotted highest score, followed by SVM and then by NB SVM. Then we can say that NB SVM will be given the lowest score. So the problems of classification here, inputs are divided into two more classes, and the learner must produce a model that assigns unseen inputs to one or more of these classes, and this is typically tackled in a supervised way. Anomaly detection can be described as a classification problem where the activities are divided into either normal and not normal. So these are the analytical parameters, the precision and recall. Of all the samples that are predicted with y equal to 1, what fraction actually belongs to class 1, that is our precision value. And for recall, of all the samples of all the data that actually belong to class 1, which fraction has been correctly predicted with y equal to 1. So this is how it is calculated. So finally we come to the concluding part where we see that hybrid and ensemble classifiers have actually grabbed attention among the researchers. Classification process carried out individually works best in individual scenarios. So with multiple features present, it does not yield promising results in terms of accuracy and computation time. Ensemble approach performs comparatively better, especially in handling vast amount of network traffic where there is a challenging task of unknown multiple intrusions and at the same time. So computation time is reduced as because naive Bayes works fast in real time, and the ensemble classifiers have the potential to provide promising detection results. So this work can be applied as a future scope. We can extend it for a wireless network also. So these are my references which I have followed. And I end my presentation here.
Thank you, Professor, for your presentation. And I think that we can ask participants for any questions to the professor. You can ask, please. As there is no questions, I want to introduce my gratitude again to the Professor Nat for this speech, this presentation. Thank you.
Thank you so much.
Now let me to introduce the next presentation, which is the hot topic today, the Edge Intelligence to Detect COVID-19 by Kazari Basak, Rajib Das, Rajarsi Bhattacharya, and Dr. Tapalina Bhattasali. Please.
Thank you. Good evening, everyone. Good evening, respected professors and fellow students. I am Kajari Boshak. Me and my teammates Rasdeep Dash and Rajarshi Bhattacharya will be presenting our paper on Edge Intelligence to detect COVID-19. This project is being done under the guidance of our respected ma'am, Dr. Tapalina Bhattacharya from St. Louis College. In this presentation, I will be talking about a few things about COVID-19, the background of our work, what is meant by edge computing and edge intelligence, and merits of edge intelligence. Rasdeep will be telling you about the deep learning and neural networks and the difference between the deep learning and traditional machine learning techniques. Then he will be explaining why deep learning is being used in edge intelligence. Next, Rajarshi will be explaining about our proposed research methodology and the future research work. COVID-19 is caused by severe acute respiratory syndrome coronavirus 2. It typically affects the respiratory system, causing cough, shortness of breath, reduction in oxygen level, and rising body temperature. It can have severe complications such as pneumonia. Some people are more at risk than others, like people of old age, people with underlying health conditions such as diabetes, kidney disease, obesity, and weakened immune system. Other group of people who are at risk are people with HIV, asthma, and even pregnancy. So COVID-19 challenges can be mainly categorized into number one, a way of epidemic prevention and blocking human-to-human transmission, and number two, live monitoring of infected or suspected person. To solve these challenges, firstly, the patient's data need to be collected and processed somewhere like cloud. But processing of the collected data in cloud on daily basis will introduce delay. Moreover, with the rapid increase in number and types of mobile and IoT devices, massive amount of data is generated, and all this data may overload the cloud, resulting in cost of computing and latency to increase. Cisco estimated that nearly 850 zettabyte will be generated by all people, machines, and things at the network edge by 2021. Existing cloud computing is unable to manage this massive distributed computing power and analyze their data. Since large number of computational tasks needs to be delivered to the cloud for processing, it poses serious challenges on network capacity and computing power of cloud. The requirements of time-sensitive applications such as cooperative autonomous driving may not be satisfied by cloud paradigm, since it is far away from the user. While clouds are powerful for storage and processing, they can create delays for IoT devices sending data back and forth. By bringing cloud computing capabilities to the local device, edge computing can process data faster and preventing delays, improving security and other concerns. Edge computing with artificial intelligence benefits each other and improves service latency as it brings resource closer to the edge. Also, edge intelligence can play a vital role in epidemic prevention and blocking COVID-19 transmission. So our aim of work is to consider edge intelligence surveillance in remote monitoring, advanced warning, and detection of person's fever, heartbeat rate, cardiac conditions to detect the infected or suspicious person, and to provide continually updated map or pattern of communication chain of COVID-19 infected person span around the community. To apply edge intelligence in surveillance for faster detection and control of pandemics. Our main focus will be to detect and track contagious person, to keep patient data record for analysis and decision making using edge intelligence. Now coming to edge computing. Edge computing allows computing resources and application services to be distributed along the communication path via decentralized computing infrastructure. Instead of storing the whole data on the central cloud, it brings data storage and compute power closer to the device or data source where it is most needed, and also reduces the overall cloud computation through distributing the task among different edges. So there is a thin line between edge analytics and edge intelligence. In edge analytics, the data is collected and analysis is performed on the captured data, all taking place near the edge. The processed data is then sent to the cloud, where it may be further processed and then perform action based on data. Edge intelligence is one step ahead of edge analytics, where action is performed after analysis at the edge itself. involving artificial intelligence. There may be an optional flow of storing metadata. The metadata is nothing but a crucial process data or report that is sent to the cloud for evaluating the performance of different edge devices. This data is also vital to analyze the actions of edge device and is helpful to make further decisions like retraining of edge models for better accuracy or retraining model using additional data, etc. As you can see, edge intelligence is merging of edge computing and artificial intelligence. Data is collected from the IoT devices, analyzed, and the insights are delivered close to where it is captured in the network. Come to merits of edge intelligence. First is speed. Since IoT computing devices process data locally or in nearby edge data centers, the information they collect does not have to travel nearly as far as it would under a traditional cloud architecture. By processing data closer to the source and reducing the physical distance that it must travel, it can greatly reduce the latency. Huge data generated at the network edge can be quickly analyzed and decisions can be made based on that faster using AI. Second is security. Since more data is being processed on the local device rather than transmitting it back to the central data center, it reduces the amount of data actually at risk at one time. Next is scalability. By combining co-location services with geographical edge computing data centers, edge network can be expanded quickly and cost efficiently. Next is versatility. The scalability of edge computing also makes it incredibly versatile. Due to reduced physical distance or latency, content providers can efficiently deliver uninterrupted streaming services. Rather than waiting for people to log in with devices and interact with the centralized cloud servers, edge computing devices are always on, always connected, and always generating data for future analysis. Even if nearby data center is not available, IoT edge computing devices will continue to operate effectively on their own because they handle vital processing functions natively. Now I would kindly request Rasdeep to continue with the presentation.
Good evening, everyone. This is Ravi, and I'll be discussing the concept of deep learning and why are we using it in edge intelligence. So let us consider artificial intelligence first and move towards deep learning. Now, what is artificial intelligence? Artificial intelligence is a technique that enables computers to think and mimic human behavior. Well, artificial intelligence is a much broader term, and from the diagram you can see that both deep learning and machine learning is a subset of artificial intelligence. Now we'll talk about machine learning. Machine learning is a technique to achieve artificial intelligence through algorithms trained with data. The machine here learns itself without being programmed explicitly. There are many ways machine learning that can be supervised learning, unsupervised learning, and reinforcement learning. Supervised learning refers to those algorithms that learn based on labeled training dataset, where the answer to the problem is already known to us, such that the algorithm tries to predict the closest acceptable outcome. For example, email classification with already labeled emails, where the machine can learn and distinguish which emails are spam or not. Techniques such as classification and regression falls under this category of learning. Classification is a process where the output variable is a category like a color, red or blue, on a class like A or B. And recursion is a problem, but the output variable is a real value object like weights, numbers, etc. Now coming to the unsupervised learning, unlike supervised learning, learns based upon unlearned data, and the algorithm tries to discover patterns and predict inheriting structure from the data. Techniques such as clustering fall under this category of learning. Clustering is a problem where the machine tries to discover the patterns or groupings of the data. For example, clustered document based on a text. Now, reinforcement learning. Reinforcement learning are the algorithms that learn to act based upon feedback or reward. But the machine observes the environment and tries to achieve goals using trial and error methods. For example, the machine learns to play Go with rewards like win or lose. Now we'll discuss the deep learning concept and what do we mean by deep learning. Deep learning is a subfield of machine learning and is a collection of algorithms inspired by the structure of a human brain in processing data and creating patterns for using decision making. In terms of deep learning, this structure of the model is also called an artificial neural network. So what is an artificial neural network? An artificial neural network simulates and analyzes data as human brain and functions when some input data is fed to it, and the data is processed by layers of perceptron to produce a desired output. It has three layers: the input layer where the data has been accepted, data layer for processing the data, and the output layer for generating the prediction. So now what is a neuron? A neuron or perceptron is a fundamental unit of the network, and a mathematical model based upon a model of biological neurons, where each neuron takes inputs, weighs them separately, sums them up, and passes these sums to an activation function to produce output. There are two popular models of neural networks: convolutional neural network and recurrent neural network. Convolutional neural network is a kind of network where the neuron in a layer will only be connected to a small region of layer. Instead of all the neurons be connected like a fully connected layer network. This connectivity pattern of the network is inspired from the visual cortex of a human being. There are many layers in the convolutional network layer, like convolutional layer, radio layer, pudding layer, and fully connected layer. The main use of this network includes image recognition. The recurrent neural network. The recurrent neural network is a kind of artificial neural network designed to recognize patterns in sequences of data such as text, genomes, the spoken word, or the numerical time series data generating from sensors and devices. LSTM or long short-term memory network are a special kind of recurrent neural network. LSTM are capable of learning long-term dependencies as well as for long periods of time. The uses of recurrent network include speech recognition, text recognition, and audio recognition. Other types of neural networks include multi-layer perceptron, back propagation, generative adversarial network, deep reinforcement learning, and deep neural network. So now we'll see what are the main differences between the deep learning concept over traditional machine learning algorithms. The first thing is high dimensionality of data. Nowadays, the data being generated all over the world are in large numbers. Thus, to feed these huge amounts of data, we need the deep learning algorithm. The second is identification of features. In traditional machine learning algorithms, the applied features are to be identified by the expert to reduce the complexity of the data and the algorithm to work. But in deep learning, the algorithm itself can learn high-level features from the data provided. Another difference between deep learning and machine learning techniques is a problem-solving approach. Deep learning techniques tend to solve the problem in an end-to-end manner, whereas machine learning techniques need the problem statement to break down the different parts of the problem first and then eventually combine in a final stage. Usually, a deep learning algorithm takes a long time to train due to large number of parameters, whereas traditional machine learning algorithms takes few seconds to hours to train. The scenario is completely reversed in testing phase. At test time, the deep learning algorithm takes much less time to run. Whereas if you compare it with a typical machine learning algorithm, test time increases the size of data. There are also differences of interpretability, where the output results in machine learning algorithms are easy to understand since the rules are already provided. Whereas in deep learning algorithms, the machine learning takes decisions based on its own logic and the reason is tough to determine. So why are we considering deep learning for edge intelligence? Deep learning algorithms have high resource demanding workload, naturally suited for edge computing. This means data generated at the network edge need AI to fully unlock their potential. As a result of the rapid increase in number of types of mobile and IoT devices around the world, large volumes of data of physical surroundings are continuously sent at the device side. So in this context, we can say that DLT is functionally necessary due to its ability to quickly analyze those huge volumes of data and extract insights for them for high quality decision making. Now the second point is low latency and low cost computing. This means IoT and edge devices generating huge amounts of data consumes a large amount of bandwidth resources, and this resources can be computed in the edge with the help of deep learning to extract information as much as possible, thus reducing latency and cost computing, which is better than the traditional cloud model, which may increase the computing time and reduce the latency. So now I will kindly request Alushi to continue with the topic further.
Thank you, Rajdeep. Good evening, everyone. I am Rajoshi. Now I will be talking about our proposed work. Our work is mainly divided in two phases. First one is to detect COVID-19 patients using deep learning neural network, and we will also prove the efficiency of the method in terms of accuracy and faster detection. We will be doing that by analyzing secondary dataset. In the second phase, we will feed this model in edge framework, and we will also find out how efficiently it can generate and spread the information of COVID patients in the community. We will be simulating the model using CloudSim simulator. Now, our main objective here is to filter out the patients for large community detections. This will not only reduce the number of test kits, but also reduce the cost of testing for individual patients. Now, to detect COVID-19, we will be using some of the main factors like body temperature, low oxygen level, age, cough, etc. People with a high body temperature, low oxygen level, old age, etc. will be more likely to be detected as COVID positive. Now, to train the neural network, we will be using the properties which I mentioned just before, like age, temperature, oxygen level, etc. The dataset may also include medical history of the patient, like if he or she has pneumonia or HIV or diabetes or any other health condition. Also, it can include location history of the patient, like if he or she has gone to any COVID positive zone recently or met any COVID patient recently or not. Now, we can either classify the patient as COVID positive or not. Also, we can classify them in multi-class, like COVID positive or not, or has pneumonia, or has chest infection, etc. It can be possible to find out these things from our dataset. Now, moving forward, here for our model, we are using edge intelligence because, as explained here, if we don't use edge intelligence, there will be drawbacks like full data sampling, full usage of bandwidth, full usage of the storage, etc. Whereas, if we use edge intelligence, these problems can easily be avoided by sensing and measuring the critical data and filtering the interpret process. So as a result, the latency, bandwidth will be reduced. Also, the data set will get reduced, so the storage will also get reduced. Now, a typical edge model contains these 4 stages. First one is sensors, second one is internet gateways, third one is edge, and the fourth one is data center or cloud. In our model, we will not be using sensor, rather the user will provide the information manually through any IoT device. Then after passing the gateway, it will get processed in the edge, taking the necessary data from the cloud. Now our deep net model will mainly contain 3 parts as discussed right before: the cloud, the edge, and the IoT devices by which the users will send necessary data to the edge. The cloud will contain the trained model. Whenever requests come from the IoT devices, the edge will inform the cloud, and cloud will then send necessary information to the edge. The edge will then process the user provided data according to the data sent by the cloud and send the result back to the IoT. Now if we take a closer look in the edge processing part, it will look like this. The user will provide data to the edge. The edge will then inform the cloud about the arrival. Then according to the trained model in the cloud, it will send the required data to the edge. The edge will also create an optimized network, and at last it will compute the result according to the data provided by the cloud. For the time being, we are not considering this part, which is local training and retraining of the model. The model will only perform according to the data provided by the cloud. Now for performance analysis for our deep net model, we will consider 2 parameters mainly. First one is classification accuracy, which is the ratio of correct predictions and all predictions. Second one is the log loss or logistic loss, which is a performance metric for evaluating the predictions of probabilities of membership to a given class. Here, the scalar probability between 0 and 1 can be seen as a measure of confidence for a prediction. For any correct or incorrect prediction, it will get rewarded or punished proportionally to the confidence of the prediction. Now moving forward, in case of future works, as in edge computing, key functions can be run without a connection to remote data center. It enables healthcare sector to monitor remote areas. It can overcome the problem of lack of specialized physicians in remote villages, as data can be provided by any user with an IoT device, and it will not be necessary every time for a physician to be present. IoT devices will be able to gather on-patient data, send the findings to their local clinic or surgery, and give almost real-time information to medical staff. Patient's data could potentially be reviewed even if the patient is not present and has not made an appointment. Hospitals and healthcare trusts could run a network of telemedicine booths that provide online, on-screen, real-time access to doctors and healthcare professionals. Patients might be able to see a doctor at their local mall. We have used these references for our project. And at last, thank you all for listening.
Thank you for your presentations. Thank you to Kazari Basak, Rajib Das, and Rajarshi Bhattacharya. I'm very grateful for your presentation of your paper. I hope that the paper will be published in the next issue of the Azerbaijan Journal of High Performance Computing, which will be published in December 2020. Now I want to ask Tapalina for the last words. Tapalina?
Yes. So I would like to conclude the workshop. It is my privilege to have been asked to propose a vote of thanks on the occasion of the 2-day international workshop on AAHIPC 2020. I, on behalf of St. Xavier's College Autonomous Kolkata and the entire workshop committee, extend very hearty gratitude to all the dignitaries, speakers, participants and presenters. We are really grateful to our Chief Patron, Reverend Dr. Dominic Savio SJ, Principal of St. Xavier's College Autonomous Kolkata, and Dr. Mustafa Babbanli, Rector ASOIU Baku, for motivating us to organize this workshop. We are also thankful to our General Chair, Dr. Panchali Sen, Dean of International Studies, St. Xavier's College, Kolkata, Dr. Rauf Aliarov, Vice Rector of Azerbaijan State Oil and Industry University, Baku, for their constant support and valuable suggestion. I take this opportunity to extend our sincere thanks to the patrons and advisory committee members of this international workshop for their minute-to-minute support and guidance, for encouraging us at every point of time. We want to appreciate our invited speakers from both the institutes for sharing fruitful knowledge, innovative ideas, and their expert opinions with us despite their busy schedule. We are also thankful to the presenters and participants of this workshop. Presenters have presented their research work very well. An event cannot happen overnight and needs structured planning and execution. We would like to thank the organizing committee, program committee chairs, and all the committee members of AAHIPC 2020 for their involvement they have shown and the willingness they have expressed to take on the completion of the work beyond their comfort zone. We also want to thank MC of the workshop from both the institutes for hosting the 2-day workshop well. We are also thankful to the conveners of this workshop. Finally, I thank all the persons who have greatly helped us in organizing this workshop. Thank you very much. And I would like to request Nigar to conclude the workshop from their side. Nigar, please.
Thank you, Tapalina, and thank you for word of thanks. I also want to introduce my gratitude to all to the principal committee of the workshop, the organizational committee from both sides, from the St. Xavier's College and also the Azerbaijan State Oil and Industry University. And I want to say thank you to all invited speakers and also the presenters of the papers in the paper presentation session. And I hope that our collaboration and the our collaboration between these two organizations, the HPC Center of the Azerbaijan State Oil and Industry University and also the St. Xavier's College, will continue the collaboration together and in different directions, such as academic, industrial, and also the periodical organizations of such workshops. And thank you again, thank you everybody. If there anyone wants to say something, want to take speech, please inform and deliver your wishes, your comments about the workshop. Okay, I think that now we can conclude our workshop. And again, thank you to all for your time and for your efforts. And see you in the next such events. Goodbye to everybody.